Welcome to STEM Baba. In this video, we'll discuss the problem and conceptual exercises of chapter 4 from the book James's Walker. So let's start. So here in this question, we are given that while walking down the street, you toss a ball into the air. Now the question here is, in what direction you should toss so that the ball come back to your hand? Either you should toss it straight up, or in a forward direction, or in a backward direction. This is the question. Now if we neglect the air friction, there is no acceleration of the ball in the horizontal direction. Thus the ball will continue moving horizontally with the same speed as your walking speed v0. Therefore you need to toss the ball straight up in order for it to land back to your hand. So the answer for the A part, it should be straight up. You should launch the ball straight up. Now in the B part, we have to choose the best explanation from the given three options. So the best option for this question will be this, that the ball moves in the forward direction with your walking speed at all the times. This is true. Other two statements are wrong. If the ball is thrown up, you will leave it behind. That's wrong. Next one we have, you have to throw the ball in the direction you are walking. That's also wrong. So this is the only correct statement. So here in this question, we are given that you are walking with a constant speed of 1.75 meter per second in a direction that is 18.0 degrees north of east. So let the x-axis represents the east direction and the y-axis represents the north direction. Now there are two parts in this question that we need to solve. In the A part, we need to tell how much time do you take to change your position by 20 meter in east. So this is your the velocity vector v, and the speed is 1.75 meter per second, and this angle is 18 degree. Now the x component will be this is Vx. This will be 1.75 cosine 18 degrees, right? And this will be 1.66 meter per second. And this will be the y component of your velocity vector Vy. This will be 1.75 sine 18 degree, which is 0.541 meter per second. Now it's pretty simple. We can solve both the part. Now in the A part, you have to travel 20 meter in east. So the value of x is 20 meter. Now time, we know it is distance over the speed. Distance that we have to travel in the x direction or in the east direction is 20 meter. And the speed is 1.66 meter per second in the x direction. So this will be 12.0 seconds. It will take 12 seconds to move 20 meters in east, right? Now next in the B part, it says how much time do you take to travel 30 meter in the north. So this time 30 meter in the north, so 30 the distance divided by the speed. Now speed, you have to take the component of this velocity in the north direction, which is 0.541 meter per second. So that comes out to be as 55.5 seconds. So here in this question, we are given that a particle passes through the origin with a velocity of 6.2 meter per second y cap. So initial velocity of the particle is along the y direction like this. Now if the particle's acceleration is minus 4.4 meter per second squared x cap, so acceleration of the particle is along the negative x direction, and this thing we have minus 4.4 meter per second x cap. Now there are two parts in this question, there are three parts in this question that we need to solve. In the A part, we need to find the positions, x and y positions after the 5 seconds. Okay, so for that we're going to use the equations of motion in x and y direction respectively. So in the x direction, we can use this equation, which is x is equals to x naught plus v naught x times t plus 1 over 2 ax t square. Now initially the position of the particle is at origin. So at origin x0 is 0 and there is no component of velocity in the x direction initially. So this is also 0 and ax we have minus 4.4 meter per second. Time we have to take to be 5 seconds. So you can put the values to find the answer. So 1 over 2 acceleration is minus 4.4 meter per second squared and time is 5 seconds and its whole square. On solving this, we'll get this value to be minus 55 meter. Now then the y position, so y is equals to y naught plus v naught y times t plus 1 over 2 a y t square. Now initially the position is at origin, so y naught is 0. There is no acceleration of the particle in the y direction, so that is also 0. So y would be equals to v naught y, we have 6.2, so 6.2 meter per second and t is 5. So on solving we'll get this value to be 31 meter. Okay, now next we have to find the vx and vy at the same time, that is 5 seconds. So for the b part we can use this equation, which is vx is equals to v naught x plus ax times t. v naught x is 0 as there is no initial velocity in the x direction. Ax we have minus 4.4 meter per second squared and time is 5 seconds. On solving we'll get this value to be minus 22 meter per second. Next vy, this would be v naught y plus ayt. There is no component of acceleration in the y direction, so this is 0. v naught y we have 6.2 meter per second. So the velocity in the y direction remains the same at all the time, that is 6.2 meter per second. Now in the c part we have to tell, does the speed of this particle increase with time, decrease with time, or increase then decrease? Okay, now here we see that at all the time the velocity of the particle in the y direction remains the same, that is v naught, and in the x direction, basically negative x direction, the acceleration is 4.4 meter per second. So in negative x direction the velocity increases at all the time. So if you talk about the speed, because vx is continuously increasing in the negative direction and the vy is constant at all the time, so the speed should increase with time. So the answer should be that speed increases with time, and the reason is that the vx, the component of velocity in the negative x direction, always increasing because of the presence of acceleration in the x direction, the negative x direction. So this is speed increases with time. And if you see the trajectory for the particle, it would look something like that. It will be a parabolic like this, and this is the position we can take after 5 seconds, and this is the velocity v after 5 seconds. So here in this question we are given that a hot air balloon is drifting due east at 2.5 meter per second. So let this be the initial position of the hot air balloon and it is drifting in the east direction. This is v naught is 2.5 meter per second, and we have taken the east direction along the x-axis and the north direction along the y-axis. Now the pilot suddenly noticed that the balloon must gain a height of 24 meter in order to clear the top of a hill. So this altitude for the hill is 24 meter and this horizontal distance is given to be 120 meter. Now there are three parts in this question that we need to solve. In the A part, we need to find how much time does the pilot have to make the altitude change without crashing into the hill. So how much time does the pilot have? This is what we have to calculate in the A part. Now we're going to use all this information and the equations of motion in x and y direction separately. So in the x direction we can use this equation that x is equals to x naught plus v naught x times t plus 1 over 2 axt square. Now, if you see the motion of the balloon in the x direction, so in the x direction it travels 120 meters and initial position is 0, so this is 0 and there is no acceleration in the x direction. So this is whole term also 0. So from here we can find the time t, this would be x over v naught x. X we have 120 meter and the speed in the x direction we have 2.5 meter per second. On solving, we'll get the time to be 48 seconds. So in just 48 seconds, the pilot have to change its altitude to 24 meters. Now in the B part, we have to find the minimum constant upward acceleration required in order to clear the hill. So AY, we have to calculate what should be the minimum value so that the balloon can cross the hill. So for that we can use the equation of motion in the y direction. So y is equals to y naught plus v naught y times t plus 1 over 2 ay t square. Now initially the balloon is at origin, so this is 0. There is no component of velocity in the y direction, so this is also 0. Now it's pretty simple. Y, that is the altitude, is 24 meter. So the value of y would be 24 meter is equals to 1 over 2 ay we need to calculate, and the time the pilot have is 48 seconds. So this should be 48 seconds and its whole square. It's pretty simple. From here we can find ay, and ay comes out to be as 0.021 meter per second squared. So this should be the acceleration of the balloon in the y direction. Now in the C part, we need to find the horizontal and vertical component of balloon's velocity at the instant that it clears the top of the hill. So it clears the top of the hill at time t equals to 48 seconds, right? So the x component of velocity is given by Vx is equals to v naught x plus axt. There is no acceleration in x direction, so this is 0. V naught x we have 2.5 meter per second. So the velocity in the x direction remains the same at all the time. Now Vy, the component of velocity in the y direction, this will be v naught y plus ay times t. V naught y, initially there was no velocity, so this is 0. Acceleration 0.021 meter per second square. Just now we have calculated this value times 48 seconds. We can solve it further and we'll get the value of Vy to be 1.0 meter per second. So we can also represent it on the figure. So at the instant when it cleared the top of the hill, it will have two component of velocity in x and y direction. In x direction, the velocity would be 2.5 meter per second, and in y direction we have 1 meter per second. This is Vy and this is Vx. So here in this question we are given that two canoeists start pedaling at the same time and head towards a small island as shown in this figure. Now canoeist 1 pedals with a speed of 1.10 meter per second, and it starts from this point and moves in a direction 45 degrees north of east. Now canoeist 2 start from this point and moves towards the lake. Now we are also given that this distance is 1.5 kilometer. There are two parts in this question that we need to solve. In the A part, we need to find the direction relative to the north must canoeist 2 pedal to reach the island. So this theta we have to calculate in the A part. Now it's pretty simple. We have to use the basic concept of mathematics to solve this problem for the A part basically. So this angle is 45 degrees, and if you consider this triangle, this right angle triangle, this is 1 kilometer and this angle is 45 degrees. So tangent 45 degrees, we have perpendicular over base. Perpendicular is 1, base we have to find, let it be x, and tan 45 is 1, so x would be 1. So this distance is 1 kilometer and this distance is 0.5 kilometer, because this total is 1.5, so 1.5 minus 1, 0.5. Next, to find this angle theta, we can consider this right angle triangle. And this vertical distance we have 1 kilometer, and this horizontal distance we have 0.5 kilometer. Now tangent theta is perpendicular over base, so perpendicular is 0.5 and base we have 1. On further solving, theta comes out to be as 27 degrees, and this would be the answer for the A part. Now next, in the B part, we need to find what speed must canoeist 2 have if the two canoes are to arrive at the island at the same time. So the time taken by both the canoeists to reach the island is same. So let the time taken by the canoeist 1 is t1, and this should be equals to t2. t2 represents the time taken by the canoeist 2 to reach to the island. Now time is a distance over speed, so let this distance is r1 and let this distance is r2. So this would be r1 over v1 and this will be r2 over v2. Now v1 we know it is 1.10 meter per second given in the question. v2 we need to find. Now we also don't know the value of r1 and r2, which we can find by using this triangle. r1, this is 1, this is 1. So r1 would be 1 square plus 1 square, which will be under root 2. Similarly, we can find r2. So r2, this would be under root 0.5 square plus 1 square. That would be equals to 1.12 meter. Now we can put all these value here. So r1 is root 2 meter divided by v1, we have 1.10 meter per second is equals to r2 is 1.12 meter, and v2 we need to find. From here we can easily find the value of v2, and it comes out to be as 0.87 meter per second. So the canoeist 2 must travel at a speed of 0.87 meter per second in a direction 27 degrees north of east. So this would be the answer. So here in this question we are given that there are two youngsters dive off an overhang into a lake. Diver 1 drops straight down, and diver 2 runs off the cliff with an initial horizontal speed v0. So the diver 2 dives with the initial horizontal speed v0. So he dives like this and then into the lake, and this is initial speed v0 in the horizontal direction. And we have to tell, is the splashdown speed of diver 2 is greater than, less than, or equals to the splashdown speed of diver 1. Okay, now neglecting the air friction, we can say that there is no acceleration of either diver in the horizontal direction. The diver will continue moving in the horizontal direction at the same speed with which they left the cliff. And if you see the vertical direction, in the vertical direction, the vertical landing speed for each diver will be identical because they fell the same vertical distance. So if you consider this is diver 1, diver 2. So for diver 1, the landing speed would be like this, let it be Vy. But for diver 2, the landing speed, there would be one component in the x direction which is V0, and there is another component same as that of first diver Vy. So it have only one component of speed in the vertical direction, it have two components in horizontal and vertical. So we can say that the splashdown speed for diver 2 will be greater than the splashdown speed for diver 1. Thus we can write that the diver speed of 2 is greater than the diver speed of 1, because for diver 2 it have two component of velocities in x and y, and in this case we have only one. Now next we have to choose the best explanation from the following. Now first statement says that both diver are in free fall. That's true, they are in free fall, and hence they will have the same splashdown speed. No, that is false. They will not have the same splashdown speed. Next it says that the diver have same vertical speed at splashdown. That's true, but diver 2 has greater horizontal speed. Yeah, that's true, it have greater horizontal speed V0. Next, it says that the diver who drops straight down gains more speed than the one who moves horizontally. No, that's totally wrong. In the vertical direction, they will have the same speed on reaching into the lake. So this would be the solution. So here in this question, we have a river fall which is approximately 108 meter high. This height is 108 meter. Also, we are given that a river is flowing horizontally at 3.60 meter per second just before going over the fall. So at this position, just at the origin, the speed in the horizontal direction is 3.60 meter per second. And we need to find the speed of water when it hits the bottom. Okay, since the water is in free fall, and there is no air resistance, so we can say that the horizontal speed will remain same all the time. And if we calculate the vertical speed on landing, we can find the speed of water when it hits the bottom. So for that, I'm going to use the equations of motion in the y direction. So we can use this equation, which is vy square is equals to v naught y square plus 2 times ay times delta y. And this is the negative y direction, so a would be minus g here, and here delta y will be minus 108 meter, right? Now we can put the values. There is no initial vertical velocity, so this term would be 0. So 2 times ay is minus g, so minus 9.81 meter per second squared times delta y is minus 108 meter. This would be vy square, and on further solving we'll get the value of vy to be equals to 46.03 meter per second. Now the speed is v, which will be equals to under root the y component square plus the x component square, so vy square plus vx square. So under root vy we have 46.03 and it's squared, and the x component is 3.60, so 3.60 meter per second, and it's whole square. Here also this is meter per second and it's square. Now on further solving we'll get the speed to be equals to 46.2 meter per second. So this would be the speed of water when it hits the bottom.